We all know that machines are becoming less artificial and more intelligent. What is artificial intelligence? It is a concept that makes machines seem like they have human intelligence. It was initially developed to make machines learn like a young child does through trial and error until it becomes smarter and more intelligent. This technology isn't new. It's been around for over 60 years. In fact, the name artificial intelligence was initially coined in 1956, and it's becoming a big thing today because of the huge amount of data created every minute from smartphones and high computing power. Artificial intelligence can be applied in various ways, from simple input to output programs to a more sophisticated machine learning. So I'm going to demonstrate a simple input program that will generate two random numbers. Then it will prompt you to enter the result, and if the result is right, you will be told that you're correct. If not, you'll be told that you're wrong, and the result will also be shown to you. So let's see how we can do this. I'm going to use Judo IDE to write this program. The codes are Java program and the IDE is Judo IDE. Like I said, we have two integer numbers here that have been declared, and here they have been initialized, but the values here are random numbers which will be generated between 1 to 50, and we declare a variable C and we are telling you to multiply the two of them, and we are saying here that it should prompt you for an answer, and if your answer is correct, you'll be told you're right. If not, you'll be told you're wrong, and the correct answer will be displayed to you. So let's run this program and see how it works. So I'll click on run, and here the system is telling me to multiply 31 times 21 to 651. System says, oh, you're right. Correct answer is 671. And here again, I'm asked another number, which is 37 times 6, 222. System tells me, oh, you're right. 27 times 1 is 20. 21 times 1 is 21. Next one is 40 times 29. 40 times 29, I'm going to give it 980. System says, oh, you're wrong. The correct answer is 1160. So that's how it works. So the second part is machine learning. In machine learning, a program that mimics it's a program that mimics the way the human brain is structured, like the neural network that help humans and now machines in solving problems. Neural networks are computing systems with interconnected nodes that work much like the neurons in the human brain. I'm going to show you the diagram of the nodes very soon. So using algorithms, they can recognize hidden patterns and correlations in raw data, cluster and classify it, and over time continuously learn and improve. So this is exactly what we're talking about. This is how the human brain works. You can see the nodes. So this is what we're trying to simulate through the artificial learning. Now, I'm going to demonstrate this machine learning with a simple example. Here, I want the machine learning to predict if text is a phrase or an incomplete sentence or a complete sentence. In this example, we have what we call the brain.js. This is a JavaScript file which will simulate what will look like the human brain. And we also have a data.json file. This is a data file that will contain all the text that we will train the brain.js on. We will train the brain.js on how to recognize the pattern of text that is stated in data.json, and once it is understood, then we can tell it to make predictions for other kind of text that are not there. So the data.json file has data that helps the brain.js learn and model the relationship between input and output as stated in data.json, make generalization and inference, reveal hidden relationships, patterns, and predictions in order to improve decision processing. So here, let's give some text to data.json that are made up of text that are characterized as either phrase, incomplete sentence, or complete sentence. Train the brain.js to learn about these texts and their categories, and test the brain by giving it some text not defined in data.json to predict which category it belongs. To be able to demonstrate this, I'm going to use a software which is called Visual Studio Code. Here, I've already uploaded the application, so I'll just show you what we have here. First of all, we have the brain.js file, which is like the central processing unit of this program. Then we also have the data phrase here, which I've used to specify different texts and their categories. For example, we have the text, we have the category, we have text, we have category text. So under text here, I've mentioned something, I wrote something, I'm great, then I'll tell you this is a complete sentence. Then text, and inside cheese nursery, this is incomplete sentence. Why my hair pink? This is incomplete sentence. Then feeling blue. So you have to write all these texts and tell the system which ones are complete sentence and which ones are not complete statement. And now you will now have to write a script that will tell the system, the script name I'm using is called phrase, that will tell the brain to learn from the data phrase and be able to make a prediction when you write something here. So we are telling you to go through this learning process 70 times before it makes a prediction. The maximum time you could have is 20,000. So again, we are telling the brain to learn from this data here. The learning process will take 70 times. We go around it 70 times, then we'll be able to make a prediction based on what I'm going to write here. Now, I wrote something here. I'm going to the market. Now, this text, I'm going to use the word text, is not in the data.json file. So what we're going to do is, once you give the system something to do and tell it to predict, you will now go around the process, go to data phrase, check what is there, rely on the brain to learn through what is there, then be able to predict if this is a phrase or a complete statement. So how do I run this? So I'll just go to the node here and type node, then you call the name of the file phrase. So just wait for a while. So the learning process has started. The system will go around it 70 times. You can increase the number. The more the number of iterations, the more accurate your prediction will be. So we'll just wait for a while until you come up with the results. To have the highest level of accuracy, what you could do is that on the data.json file, you have to give it as many data as possible. So the fact remains that the more data that you give and the more iteration steps that you also give, the higher the percentage of accuracy you have. The system is telling us that, well, I've checked again and this is the complete statement. So let's say I am going there, I come here and type node phrase. Let's see what the system is saying. I'm going there. Let's see what the system will tell us. Is this a complete statement or is it an incomplete statement? I am going there. I did not specify where I'm going. The system is telling us, okay, this is a complete statement. So let's be sure. We can run this again for the last time. Let's see what the system says. The first result was that it's a complete statement. The second result that this is also a complete statement. So that's how neural network works. So I'll continue. So now we've given some text and we've seen how the prediction comes. So that's a little screen that shows the Visual Studio Code and how it's set up, something you can learn if you contact it. So why do we need to use neural networks? Why is it important? Neural networks are also ideally suited to help people solve complex problems in real life. For example, the credit card fraud, the Medicaid fraud can be detected using the neural network. Uh, the character and voice recognition can also be detected using the neural network. You can do medical and disease diagnosis using neural network. You can also carry out financial predictions for stock prices, currency, bankruptcy, and bond ratings using neural networks. You can do robotics control systems using neural networks. You can check for electrical load and energy demand forecasting, even things on weather, flooding, you know, rain, the duration for rainfall, predictions for rainfall, flooding, all that can be done using the neural network. Then, of course, you can also do what is called image recognition and voice recognition, video recognition. All this can be detected. Even facial recognition, they can all be detected using neural network.